This is TWIS. This Week in Science, episode number 787, recorded on Wednesday, August 19th, 2020. How to Save a Cow. I'm Dr. Kiki, and tonight on TWIS, we will fill your head with spiders, politicians, and fake eyes. But first, thanks to the Burroughs Welcome Fund and our Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer, disclaimer, disclaimer. The following program has content pulled from the previous week's release of scientific stories. The content itself was created by scientists, researchers adept at revealing the secrets of the universe, the stories of planet Earth, the mysteries of life, and the systems by which life manages to survive on a planet spinning around a star, spinning in a galaxy, just one of such galaxies out of billions hurtling through space. And while the significance of human achievements may be somewhat limited in respect to the size of the universe, the expanse of our knowledge need know no limits. On This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
A good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We're back, we're back, we're back, we're back. We've got all the science that we could fill in our heads, in our shows. Actually, there's a whole bunch of stories I'm not even going to talk about tonight that are so good.
Wow.
There's a lot out there, everyone. There's only this time now for us to talk about the science that we did bring. I have stuff about mystery gas. I have another story about sensing when you're drunk, and a story about breathing. Justin.
Some sound effects coming from Justin right there.
That's the use of getting sober when you gotta get drunk. Oh yeah, what were we talking about?
What'd you bring, Justin? Yeah, how's that jet lag?
It's fine. It's really fine. There's no problem at all.
No problem. Okay.
No problems at all. I have got some stories. This is an amazing one. I got a story about regeneration of cartilage. Places where we didn't think cartilage could get regenerated by the body. Also, there is a potential, not treatment, mind you, but cure for the common cold sore.
Oh.
As well as... yeah, that's a big one. That's a removing latent virus from a body thing. That's going to be fun. And then, there was something else, which is totally, yes, the political speaking over time. Some researchers looked at how our political discourse has changed over the time. And the results
It has
probably
changed.
won't surprise you. Yeah.
Probably not.
Okay, fine.
Tonight at
That was the
11.
story.
But there's more news that
And the
won't
show's
surprise
over.
you.
That would be great, though. Every time they did a teaser, there was another anchor who was like off to the side who guessed that story. Like, well,
I totally know the answer to this one. All right, Blair, what's in the animal corner?
Oh, I have bird songs, baby talk, and of course, slingshotting spiders.
Pew pew. Slingshots. What? Spiders have so many tricks up there.
So you go back
They
in
don't have
time in
sleeves, but-
Starship Enterprise.
Oh yeah, slingshot around Mars or something.
I don't think the spiders are doing that yet.
No,
maybe in another galaxy.
Slingshotting spiders yet.
Not yet. As far as
know
we're
of.
aware.
We know of.
Oh my goodness. We've also got our COVID update this show. We've got so much more in the show. Just get ready. Get ready because we're jumping in right after I remind you that I'm going to do right now that if you're not subscribed to TWIS, you can do that by looking for This Week in Science on YouTube, on Facebook, and in just about every podcast provider that is out there. We're on Spotify, Spreaker, radio.com, TuneIn, Apple, Google. We're there. So you can just look for us, This Week in Science, or just go to TWIS, TWIS.org, twis.org. All right, let's get to the quick stories. Quick. Take a breath. Just take a breath. Yeah, when you think of breathing, respiration, what's the first thing that you think about?
Your lungs?
COVID-19. Oh, wait.
Gosh. No, the COVID update is a little bit later in the show.
Oh, okay.
But yeah, most people think of respiration or breathing as the act of taking a breath, inhaling, exhaling, that it's your lungs, right? Well, it goes so much deeper. And we have, of course, these amazing molecules in our bodies, the oxygen-carrying hemoglobin molecules, that when they grab onto oxygen, that really is the breath, because they hold the oxygen until they can take it to places where it's needed in the body to deliver it to the tissues, to the cells that will use the oxygen in the cellular respiratory processes. So it's really the fundamental first step of breathing is not taking a breath, but that grabbing onto oxygen that hemoglobin does. And when it does grab on to oxygen, it goes from this kind of relaxed state to a tight state. It's like kind of loosey-goosey, and then it gets this domed bulge to it. And you could think of it kind of as the stereotypical image of the red blood cell, where it's like indented in the inside, like one of those weird water frisbees that you might have played with where they're inflatable. And anyway, I'm getting off story here.
It's like a bowl shape.
Like a bowl.
Bowl shape.
Yeah. And that bowl could get filled with oxygen, and then it gets kind of bulgy when the oxygen is in it. But the big debate among chemists has been, how does that shift in the shape of the heme take place? Is it through thermal dynamics, that there's actually heat energy in the molecule, that it's either tighter or looser, and so there's more vibration or less vibration? Is that what's going on? Or is it an electron cascade, where electrons, they've got their spin and they spin into each other, transferring their energy down the line? So these researchers in Germany and Japan, they were looking at using the Japan Synchrotron Radiation Research Institute's free electron laser to produce X-ray emission. And they shot it at these oxygen-carrying heme molecules as they were taking oxygen up. So they got this very clear, very sensitive, high-resolution, like femtosecond picture of the spin state of these molecules, the electrons in the molecule of the heme. And they discovered that, no, it has nothing to do with thermal expansion or relaxation. It's electrons spinning around and exciting each other. And that is what allows the hemoglobin to change shape and hold on to oxygen. So it's really electric transmission within the molecule itself that allows us to breathe, to go like this, because we'd never be able to do that if it weren't for the electrons in the first place.
Thank you, electrons. You do so much.
Thank you, electrons. Yeah. And thank you, technology, for allowing us to be able to create these amazing X-ray pulses. I mean, X-ray lasers, allowing us to look at these not even second by second, femtosecond by femtosecond changes in the shape of the molecule. It's crazy stuff.
Yeah.
Anyway, crazy little tiny details. They excite me sometimes. We can look at these things now. It's very, very
Electrons are very exciting.
Mm-hmm.
They are exciting. Yes. Negative. Tell me about some negative words. Tell me about those politicians.
So this is out of Kansas State University. They analyzed 2 million congressional speeches made by both Republican and Democratic legislators, starting back in 1873 all the way up to 2010. They used computers to analyze those speeches because it's just too much boring reading for even entire university of students to take on. In the research paper, A Data Science Approach to 138 Years of Congressional Speeches. This was published in the journal Helion. K-State computer scientist, students Ethan Tucker, Colton Capps, and computer science associate professor Lior Shamir used text analysis algorithms to analyze these speeches over the years. The research results, this is quoting voice of Shamir, research results show that more recent speeches use a smaller vocabulary, simpler language, express more positive or negative sentiments, and have more noticeable differences between Democratic and Republican speakers. As, according to Schmier, that's compared to over time. That's sort of the trend. The algorithm measured different aspects of speeches, vocabulary, reading level, positive, negative sentiments that were being expressed. Based on the analysis, part of what is sort of interesting here is that they found that the sort of becoming more positive and more negative also became more dependent on who the president was. So if Bush was president, the Democrats were very negative, used a lot more negative words in their speeches. Then when Obama was president, it became the Republicans who spoke very negatively in most of their speeches. And the level of the dialogue has been decreasing. So let me see if I can find where it's laying out. But in the 19th century, we tended to have speeches that were around an 8th grade level. And that went up until the peak was in the 1970s, mid 70s. We were at around a 10th grade reading level. Since then, we've gone back down to an 8th grade level in just 1976 to the present. We've just absolutely gone down. One of the things that they think might be responsible for this trend is the fact that people are now, politicians are using media to give their speeches to a base. And they're using simpler words, and they're using this more positive or negative, depending on who's the current administration in the White House. And they're not using these speeches to talk to each other any longer, but using it as a sort of their own infomercial to the base. Another possibility is just people are dumber than they were, 40, 50 years ago. And all language is sort of like showing that.
I think language is different. If I think about it. So first of all, every time I go to Disneyland, I go to the Great Moments with Mr. Lincoln. And I listen to the Lincoln speeches there by the animatronics. And it always astounds me how eloquent and flowery it is. It sounds more like Shakespeare than like a president talking, it's kind of lots of metaphor, big words, flowery language. But also think about like, if you ever watched Civil War documentaries, the letters,
those letters back home.
Letters, my dearest Matilda. Yeah. So, right. So it's just, colloquialism is different. Language is different. It's less formal in general. And I
think that's true. The formality is less. But I wouldn't say that people are getting dumber. I would say that I would agree with the media aspect of this, that if you are preparing a speech to be given over television or even the radio, it's very commonly understood that you want to write for somewhere around a 6th grade reading level or reading comprehension level, not because they expect people to be educated at that level, but because people are busy doing other things. They're taking care of their kids. They are having dinner. They are doing other things and not necessarily just sitting and listening to you.
Well, and things are boiled down into little bites more often, right? So you might read the president's speech in the newspaper in its entirety in the late 1800s, early 1900s, and so on. But now it's 2 sentences. That's all you get. So you're not going to use a bunch of flowery language. You're going to get straight to it.
And in the 1800s, it wasn't as much of a as much of a representative government. It was representative in the sense that there were landowners and members of the elite class who were chosen by other members of the elite class. They were chosen by a smaller percentage of the population, and so it was a different segment of the population that was being talked to. That they were trying to convince of certain things.
I don't know that that's absolutely true of the mid 1970s.
Right? Yeah. No, not 1970s. Everything was the same.
Peak. That's when we had peak vocabulary, and it had been going up in that century all the way up. It had been largely positive, generally, the speeches that were given, regardless of Democrat or Republican or who was in the administration. It was only after then it started going into that split of having to say the negative thing or always saying the positive thing, the sort of sycophant versus the resistance situation. Now, again, this ends at 2010. This is that's the
data. That's the data that they analyzed. They didn't.
That's the data that they analyzed. So
they could have analyzed further. What I love seeing, though, is that the last kind of 5 years, it looks as though the Democrat line, where they paralleled each other for the whole time, it looks as though they are diverging in the end of the graph, which I find very interesting. And who knows if that continued? Who knows how it moved? But I think, modern television, modern news cycles. I mean, there are a lot of things to explain it. I mean, but yeah, fascinating.
Yeah. This is, but I have some sort of I get there's a clarity of message. You can use simple language, and that alone should be okay. But if we all agree to that at all times, and this continues, we just dumb down language that is understood by people because they don't hear it. They won't read it. They won't hear it. Their politicians won't speak it. Their media doesn't speak it. Their entertainment won't speak to it. Their anything written won't speak to it. And you will get a continually less articulate population as a result. I don't know if that's really a positive thing.
I mean, what was it? The 50s and 60s were the beginning of the big marketing kind of pushes. And I would imagine, I feel like marketing and communications has become a real skill over the last 50 years, 60 years. And that ability to convince people to buy something, to do something, it is very often simple language. Don't confuse people. Don't add a whole bunch of unnecessary details. There are all sorts of little tricks that people who are in marketing and communications understand. So
it's just waiting for that eventual debate of the future. America, good.
No.
America, very good.
Well, I think if I may throw one more thing out
there we go.
I think that I think about this downturn is pretty similar to when the Tea Party started happening, right? And I think that one of the main tenets of the Tea Party when they first showed up was those elitist leftists are talking over your head and they don't think you're good enough, and we're going to tell you the basics. We're gonna be truthful to you. We're not talking. We don't think we're better than you. Sort of conversation. So it could be
billionaire tycoon funded organizations,
right?
We just understand the price of milk, whatever that is.
I'm not defending it. I see the irony, but I think that is definitely the main tenet that they rose within, and so you could see how that would push the verbiage kind of down.
No. I don't believe that the working class of America is illiterate. I think people will rise to the context of the conversation.
That was the rhetoric. That's what I'm saying. Is they're saying they're trying to flowery up the language and not give you the whole truth. We're going to give you
wasn't that part of the thing with Bush second getting him into office was he's he doesn't talk down to you. He's someone you'll want to have a beer with, and there was a big push around that. I don't know.
Somebody who's trying to put food on your family.
That's right. That's right. That was nicely
trying to put
done.
Food on families. That's what I'm trying to do.
Nicely done. All right, Blair.
Yes, that's it, right.
Spiders? Yes, slingshotting spiders. Did you know those were a thing? Yeah,
wow.
if you're an
Bungee
insect,
jumping.
if you're an insect in the Amazon rainforest of Peru, you might catch yourself being slingshotted at by a spider. This is a study from the researchers at the Georgia Institute of Technology. We've actually known about these Peruvian spiders for a while. They were discovered back in 1932, slingshotting around. But the mechanism behind it, the why of it, the how of it, has still been a question mark. And so the Georgia Institute of Technology sought out to figure out how this worked exactly. So when the spider weaves a new web every night, they create a complex three-dimensional spring. And if you look at natural silk spring, the spring, what it's made out of, carbon nanotubes or other human-made materials have similar power density or energy density. So this is a pretty intense contraption. It's actually more powerful by several orders of magnitude than anything man-made we've ever seen before. And so there's a bunch of questions. How does this web store energy? How does it provide new sources of power for potentially robots? It always comes with that. How can we make our robots more like spiders? I feel like this is always what it comes down to.
Yeah.
And how we can use that on more robust materials. So they make this three-dimensional conical web. There's a tension line at the center, and this little spider is about 1 millimeter long, pulls the tension line with its front legs to stretch the structure, and holds onto the web with its rear legs. Now, if it was just holding this tension, they hold it for hours sometimes, waiting for something to fly by. It would rip their legs off, probably. So there's something else going on. There appears to be some sort of catch that they can then release. So they looked at this kinematic study. They saw that it had an acceleration of about 1,300 meters per second squared. That's 100 times the acceleration of a cheetah. It had velocities of 4 meters per second, and subjected the spider that was flying to approximately 130 Gs. So that's more than 10 times what fighter pilots can withstand without blacking out. So they have this spring that creates this ultra fast motion. They can hold the ready to launch spring for hours. And this latch mechanism, it appears to be like basically a hunk of web. And if they release it and they miss their food as something flies by, they can actually pull the tension line back and reset. They don't have to build a whole new web. So they also think they're using an acoustic sensing technique to figure out when something is flying by, because researchers got these spiders to eject by snapping their fingers near them, which is pretty wild. And so they have a little bundle of silk that they have on the tension line. They release the bundle, that's the catch, and then they fly. Both the spider and the web move backwards. Stretching the web actually requires at least 200 dynes, which is a tremendous amount of energy. And so they have a trick to lock their muscles with that latch so it doesn't consume energy while they're kind of poised for attack.
Right. It would be kind of like a ratchet.
Yeah.
Kind of probably a ratchet kind of system where it won't go backwards until you release it.
Yeah, absolutely. So basically, these guys are just super powerful, super strong. The silk itself is very strong, and then the methodology of the latch and release is something that is really wild and could potentially be used in man-made things.
Yeah, so spider silk is a thing, and isn't that stronger than steel? So this is like having a
depending on the
cable.
test you're running, for sure.
Okay, but if this is like a steel cable that you can actually stretch, and it's going to go back to its like it sounds like it could store quite a bit of energy.
Yeah,
I'm imagining though the uses for this. So yeah, okay, we could figure out how to use this in robots, but I mean, we need to update like that circus sideshow act where people get shot out of cannons.
Yes. Spider slingshot?
Spider slingshot, exactly. Or this is the next extreme sport.
Perfect. Yeah. It's actually, we should have an entire, like X Games, an entire event that is all based on spider feats.
That would be amazing.
Yes.
Television
Balance.
producers, we have an
Yeah.
idea for you. Come talk to us.
Balance. Gift wrapping would be one.
How many times the G-force
Well,
with the pilots?
Oh, I think it was 130.
130 G's.
So people might die.
Maybe.
In the spider
people will
event.
definitely die from this.
We have to get some waivers signed for sure.
We don't want anyone to die. Oh, no. All right. I have another story about how can you know when you're drunk? How can you really know? I mean, how do you know when your blood alcohol level is 0.08 and you will go over the intoxication limit? Should you be stopped?
Best way to tell.
Yeah.
If you've had a drink and you think you can drive, you're probably over the limit.
You shouldn't. Yeah, you're probably over the limit. Exactly. Well, people make poor decisions. They decide that they can go and do things they probably shouldn't. And the more they drink, the poorer those decisions usually are. So researchers are trying to figure out how they can use devices that people have around them all the time to be able to help them make better decisions. Smartphones. So a group of researchers from Stanford University and the University of Pittsburgh used accelerometers in the phone, in your smartphone. They attached the phones to people's backs and then had them walk around down a hallway after having drinks. And then they used the accelerometers to try and predict how drunk people were, to try and correlate their movements and what the accelerometers read to actual blood alcohol levels. And they found that they were able to very accurately determine that correlation. So they were able to predict when people were over 0.08 blood alcohol content based on how they were walking at 92% accuracy.
Wow.
So really great
I immediately have a
accuracy.
question as a person that is incapable of walking in a straight line when sober. Do they have a baseline? Like, do they measure things before the drinking starts?
Yes.
Okay,
They did start with a no drinks baseline and then at different time points after the drinks. What they found is that there is a very high correlation, a very strong relationship between the side-to-side sway of people's hips and how intoxicated they are. And that can be used
more loosey-goosey.
It hits the hip sway. So even though you might not be able to walk in a straight line when you're sober, you probably move differently. And perhaps your hips move differently when you're intoxicated than when you're sober. And that is not necessarily reflective of whether or not you can walk in a straight line.
I notice drunks tend to have a lot of upper body sway. That's not necessary. Like not while walking, but like standing still, there starts to be this sort of like,
swaying,
constant need to sort of just be in motion, to be tracking what balance means.
Yeah. The goal of this research is to hopefully at some point have an app that you can download onto your phone that will just monitor you walking around while you're at a bar, while you are at a party, and potentially send you a message or a notification when you hit a certain amount of sway.
Jesus is like, hey, I hope you have a plan to get home because it ain't going to be the car.
It's not going to be the car. Your Uber and Lyft have been cut off. No.
So that's a pretty cool idea.
Uber and Lyft.
That's a pretty cool idea. Although you can get pocket-sized breathalyzers that run on batteries that, you can blow into and will tell you.
That also probably don't have as many privacy concerns. I mean, this is trying
it's
to
not sharing
use
the data with anybody but you.
Yeah. And it's not necessarily, you download an app and you have to give all sorts of permissions. It's like, no, I don't need you to have access to all my contacts list to be able to monitor.
But if you sold a phone that not just an app, but just had a built-in breathalyzer, like I don't think the phone manufacturers are thinking far enough ahead. You don't need little kickstands, little magnet thing. We'll just add a breathalyzer to the back of the thing. People will buy it.
Yep. Yeah, so more research obviously always is necessary, but they're trying to develop a tool that would, an app that could work with your phone so that your phone would be in a purse or a pocket and it could fairly accurately determine whether or not you are over the limit, honey.
I didn't bring the story this week, but they're working on a breathalyzer test that will test for COVID.
Yeah. Well, that's cool.
Can you imagine having that on the phone? Or even better yet, just have like a tiny little fan that's pulling air through the analyzer on the back of the phone case and tells you if it's it's like you've been exposed somewhere here, leave immediately, It's all sorts of cool things. We have this giant technology at the palm of our hand, and it's being used for like games and calendars and stuff. It's kind of...
Yep. Well, like I said, privacy. People like their privacy, but our phones could be used for so many good things. Tell us about another great thing that's happening, though, Justin.
All right. This is researchers at Fred Hutchinson, which I assume is a cancer research center and not a person, have used a gene editing approach to remove latent herpes simplex virus 1, also known as the oral herpes, in animal models. The findings showed at least 90% decrease in the latent virus, which is enough researchers expect it will keep the infection from coming back. Now, what is this latent virus? This is virus that has accumulated in cells and then regenerates in those cells, exits again, and reinfects the body. It sort of keeps happening. This is a study that is published August 19th, Nature Communications. Kind of an interesting approach. These two sets of genetic scissors that targeted and damaged the virus's DNA. They fine-tuned the delivery so it went more specifically to the area of the infected cells, targeted nerve pathways that connect the neck with the face and to reach tissues where the virus lies dormant with the people with this infection. Sort of interesting is that these scissors that came in caused damage to the DNA of the virus. But then that was it. That's all they did. And because they were now recognized as damaged, the body's natural pathways of removing damaged junk took over and flushed out those DNA remnants.
Right, all the bits that are left.
Yeah, all the bits that were left as well as whatever's attached to it also went. So they didn't really have to be targeting like, this is the mechanism that we need to cut that allows it to XYZ later down the road. As soon as they damaged it, the body was like, oh, something's broken here. Let's remove it. Whoosh. So they are also looking at, this is a bigger number than I thought. I need to stop sharing water with people. Two-thirds of the world population under the age of 50 have oral herpes. People over 50, I think, all have it. According to the World Health Organization, the infection primarily causes cold sores and is lifelong. It doesn't go away. You don't get over it. The virus not magically going to one day be gone. Oh, well, unless science does something like this, and then magically, miraculously, scientifically, with lots of research scholars. Granted, these scientists, Fred Hutch, it will be gone.
It'll be gone.
So, based on the success that they've had thus far, they are also looking to pursue a similar strategy to attack herpes simplex 2, which is the genital herpes, which is before AIDS was the biggest risk of the dating scene. Maybe one of them. Kind of big deal.
Herpes, yeah, it was a big deal. Mm-hmm. It's forever.
It's forever. But
yeah, maybe not.
Wow.
And then because that's like, for all the people whose free and carefree lifestyles were ruined in some way by, it's for life. At one time, yeah, it's for life.
Well, it's tough too because it's not one that general safe sex practices can prevent. Really? So,
yeah.
I think that's the thing that really is a bummer too. If you're otherwise safe, you can still get herpes.
Yes.
Yeah.
Yes, because you can get them from a toilet seat. Wait, what are you saying?
No, because just general birth control techniques.
Oh, right. You need to wear
things like that.
You need to wear a condom.
Yes, but you can still, if somebody has a flare up, you can still get it even with a condom.
I did not.
Not as easily, though.
Not as easily, but you still can. Yeah. Which is why I think it's always felt like such a bummer to me that like you can follow all of the steps, but if you're not doing that one step where you're asking people to get tested before you engage in activities, then you can still get herpes.
That's the best way.
Which is the one that is until now incurable. It just feels so unforgiving.
It still is.
It's a real big
still incurable.
The only one that they think they've really gotten so far out of this is the oral one. So the cold sores, those little marks there, I guess on the inside, the cheek or the tongue, somewhere in there.
Usually on the lips.
On the lips. Okay. Mm-hmm. Outside on the lips is the. So that one is.
It's nice to see that there's progress happening.
Absolutely.
Eventually, once they get past the animal models, hopefully it'll work in humans and they'll be able to actually have this be a treatment. And oh my goodness, what a huge step forward. Because we've talked about on the show before the fact that like herpes has been with us for almost as long as we've been human. Like even it goes back to, I think it goes back to the apes even. Like the herpes virus is, I mean, it's been on this planet.
It's smart.
It's a smart, successful virus, but oh my gosh, can we get rid of it?
If you want to be a successful virus or a parasite or anything, attack the things that people use to have sex.
Because those are protected.
They're going to use those. They're going to use those. You know it. So.
Oh, we'll just try and keep COVID away from that. Yeah. Let's talk about some eye spots. Eye spots. So, researchers.
What are you saying? Ice pots? Eye spots?
Eye spots.
I still can't hear. I'll hear the story. I'll catch up.
Eye spots. Eye spots. Like on butterfly wings, how many animals have what look like eyes in their coloration can potentially help avoid predation. At least that's the hypothesis. That is the working hypothesis to date. A researcher in Africa was looking at farmers with cattle and realizing that their cattle were getting predated and eaten at a fairly high rate. And he said, oh, hey, why don't we try this thing? And he tried it a while back with like 1 cow or 6 cows or something and painting eye spots on their rumps. And it seemed like the eye spots scared the predators away. And so he did a bigger study. And that's what's published now in Nature Communications Biology. Artificial eye spots on cattle reduce predation by large carnivores. He found, and the group of researchers, they got a bunch of ranchers to paint their cattle with eye spots or not with eye spots. And then they looked to see who survived. They found that cattle that had eye spots painted on their rumps were significantly more likely to survive than those that had no eye spots or that had just crosses on their rumps. However, just crosses on the rump did seem to have a little bit of protective ability, which was interesting to them. But really, eye spots, high survival for the cows that had butts with eye spots. Why haven't cows evolved this on their own? I don't know. Probably because humans were involved and eye spots don't help against the humans. But this could help protect ranchers and their cattle from big cat predation moving forward, and potentially protect those animals as well, because if the cattle are not being predated, then the big cats and big predators, which we know are, these animals are at more and more risk as humans expand their ranges. People aren't going out and hunting them anymore.
Okay, so important question. I know I usually talk about human studies and I turned it into animal stuff, but I'm going to take an animal study and turn it into a human thing. So with COVID, and everyone inside way more. Going out for a run feels a lot more scary, especially in California, because mountain lions. So I'm proposing a new line of running gear for humans that has eye spots on the back.
Yeah, put them on the butt.
Great idea.
Yeah, on the butt, on the shoulders, any of it.
Big eyes. Yes, and big eyes.
It's just confusing. I'm picturing, the two lions sitting in the savannah at the end of the day, and one lion's turning to the other. It's like, I'm telling you, Bob, I'm chasing this thing full speed, and it's running backwards, just staring at me the whole time. It was the weirdest thing. I'm used to creeping up behind a thing and, catching them from behind a little bit. This one's just staring me right in the eyes, running backwards.
Those eye spots.
It was the weirdest thing.
They look like lion eyes, specifically.
They look like lion eyes.
They kind of do. Yeah. That's pretty clever.
That was the other thing I was wondering, if it was just eyes like on a butterfly. But see, even the butterfly eye spots are supposed to look like great horned owl eyes.
Oh.
Which are the main predator.
Right. Yeah. So they made it specifically look like lion eyes.
Apparently it's very successful. So
turns out people who wear Puma backpacks are less likely to be attacked by mountain lions while jogging.
Well, yeah, eye spots on the back of your Lululemons. It's going to be a thing.
It'll be a huge thing for all those rural runners.
Not even rural anymore. That's what I'm saying. There's mountain lions.
That's right. Actually, everywhere.
Oh, wow.
Oh my goodness, you're right. They're all.
Well, they run in from the wildfires, maybe too. Oh, jeez.
Oh gosh. At anywhere that people and wildlife collide, there can be issues. But eye spots, they can potentially solve a bunch of problems. If you just tuned in, you're listening to This Week in Science. If you are interested in a TWIS shirt or a mug or face mask or other item of TWIS merchandise, head over to twis.org and click on the Zazzle link. The Zazzle link is where you can find all sorts of products, fun things, and support TWIS. Time for the COVID update.
COVID update.
This just in. Hi.
Okay, so cases in the United States are on the decline overall, although several individual states are continuing to experience cases or even increasing spread of cases. Generally, the trend suggests that there should be a reduction in deaths appearing in the data in the next few weeks because deaths lag cases by several weeks. And that would be a welcome change considering the United States has been averaging over 1,000 deaths per day for several weeks now. So it would be nice to see those numbers start to come down. But we've been staying inside. People have been isolating. How are people coping? We've potentially seen and read and heard stories of mental health being a major concern as social isolation goes on and on and on. Researchers at UCLA were especially concerned with the population of older adults who have been diagnosed with anxiety and depression, and were concerned about that particular subset of the population that are isolating, having larger or deficits, problems, even further problems with their mental health issues. Anyway, the study that they did, they interviewed a bunch of participants over the age of 60 who were screened for their anxiety and depression, and then and that was before and after the pandemic. And they pretty much determined that, number one, participants were more concerned about the risk of contracting COVID-19 than the risks of isolation. So they were like, I don't want to get sick. I will stay home. I'll do what it takes. So they are maintaining physical distance. Many of them are not feeling socially isolated because they're using virtual technology to connect with people. And this is potentially something they're doing more now than they did before because it's become more widespread generally. A lot of them said that their quality of life was lower, and they worry that with continued isolation that their mental health is going to suffer. And Participants were generally upset by the inadequate governmental response to the pandemic. But overall, they found that they were worried about this population, and the population was actually resilient. And that because they had been dealing with depression and anxiety for a period of time before the pandemic occurred, they already had tools in place to be able to deal with mental health issues.
Did you say this is people over 60 specifically?
Yeah.
So they've been through some stuff.
They've been through some stuff.
Resilient bunch.
Yeah. Yeah. So it's a little bit of, for right now, positivity in, there are people, we're concerned about people. We want people to be doing okay. And this is a hard time. And it's kind of nice to see that there are people who they're not doing, great, but they are doing fine. They're making it through. So, keep an eye on people, check in with the people that you love, but it's good to have some good news occasionally. Blair, do you wear a face shield when you are interacting with people or just a face mask?
I wear a face mask. And if I feel like I'm doing something especially risky, lots of FaceTime with lots of people, I will wear goggles.
Oh, yes, because the eyes are a route of infection.
Yes.
Yeah.
Yeah.
So goggles can be really great. There was a study that was done in Chennai in India where a group of people, healthcare workers, volunteered to stay in a hotel to isolate away from their friends and family and to go out into communities to do social contact tracing with people who had potentially come in contact with people who had COVID-19. And so, of course, many of the people in that population ended up having COVID-19. And initially, when these healthcare workers went out, they were isolated by themselves in hotel rooms. They were chauffeured in vans that had steel plating between the driver and the passenger part of the van to minimize air contact, viral contact.
Messing around.
They were not messing around. And these were public health professionals who knew how to wear masks, who knew how to take care of themselves. They wore masks going into these families' homes, doing their contact tracing. Many of them got sick. So they shut the whole program down. They went back, they retooled, they got more volunteers and eventually started the program back up again. Only this time they used clear plastic face masks in addition to the breathing masks, the respiratory masks. And with larger numbers of contact tracers, with larger numbers of people they interacted with, and with larger numbers of COVID-19 positive individuals that they interacted with, nobody got sick.
Wow. So that's a good combo then.
That's really good.
It's amazing. And they don't know what exactly happened to make the change. The only thing that was different in the methodology was the use of these clear plastic visors. They think it potentially stops airflow, that it maybe breaks things up a little bit. It's an additional layer of shielding, but to know that there is some massive additional protection potentially based on that simple change is an exciting development.
There's also other things like this jump out, like, okay, maybe wearing this face shield means people are fidgeting less with their masks because then they would have to be removing a thing to fidget with the thing so maybe there's
lift it up, move it over. Yeah, you can't itch your nose as easily when you've got a plastic face mask in the way.
Let it roll. So fun COVID update. So I just flew on an airplane. Terrifying. Thankfully, the flight was empty enough so that even it wasn't a full flight at all. Everybody got to sit a really decent distance away. Nobody had to sit next to a stranger on this flight. That part was pretty cool. The plane circulates air every 3 minutes, and everybody was, of course, having to wear face masks. And I brought enough to sort of change out during the long flight. Within an hour of landing, I was directed to a white tent. Where I got my free COVID test.
Oh, sure.
24 hours ago.
because you left the country. You did
Right.
not come to the United
Not
States.
within the United States.
This is not within the United States.
This is in Denmark. This is in Denmark. This is to be clear. I got a free COVID test, and results came back within 24 hours. I'm going to take another one in maybe a week. Because of course,
are you required to stay where you are in between?
Yes, until I get the result. So the result is clear. I'm going to take another one because they're free, and because if showing up not having had COVID is fine, but I'm not worried about that airplane ride. Like, who knows? That's just the closest confines I've been with a group of people who are strangers since this whole thing began, and for a pretty long period of time. But it's such a day kind of like I couldn't go and get a test in the States and have it with that quick for any dollar amount. So
that's amazing.
The difference
that's the difference. That is the difference.
And this white tent isn't just at the airport. They're apparently all over the city of Copenhagen. And if you have a concern or just want to relieve your stress level or anything, you can go there, get the swab. It was really quick. This was a drive-through. We just drove through. They had the face mask, shields, and stuff going on, and it was a throat. Didn't go at the nose. They did the back of the throat, and then off you go, and you'll get a text message.
So civilized.
Yeah, like why is it that it's just what's going on?
There's not a lot of point in asking why at this point.
How is the disparity this ridiculously different?
Yeah.
I don't understand.
Because it was ignored for a long time. But I think one thing that's important about the face shields is it's an and, it's not an or.
Yes, it's an and.
So
it adds extra protection.
You can't say never mind with the mask unless
you have to do
that
both.
face shield is sealed to your face completely. Like you have your own air system.
Like
otherwise,
you are an astronaut.
Yeah, otherwise
or
you
a scuba
still
diver.
need a mask as well.
So I did Blair wear that face buff thing that did so poorly in the test. I wore that above the medical grade mask.
Oh, great. Yeah.
So I still doubled up. I knew like, okay, this thing it's alone isn't effective. This one is supposed to be the good one, the medical grade. But I put the other one over it just because I could still breathe and more is better.
More is better.
And it probably kept it from moving around too much and all that kind of stuff.
And you could actually lift it up higher and then it could work like the blindfold in the flight.
Oh, yeah.
Then you can go to sleep on the flight, which is what you always
like that ostrich sleep
I never fall asleep
mask
on a
thing.
I tried, but I can't fall asleep on
There's a question as to whether or not people were protected by regular glasses in this study, and I don't know the answer to that question, but that is one point that the authors to the study did bring up, which is potentially these the plastic face shields provide eye protection. And maybe that is what is adding the difference. They don't, like I said, they don't know, but it could be this additional reducing the infectious routes.
Or just like in that same vein, getting the COVID virus landing somewhere on your face. And then you're out of public and you're thinking, okay, I can take off my face
mask. You're not touching your
rub
mask
my
as
eyes, and like now I'm out of public. Now I can touch my face. I wash my hands. I did all that. 20 seconds under soap. Now I'm like, finally get the mask off. And now there's on your face, and you just smeared and smushed it all into
evil, invisible glitter.
Yeah. Oh my goodness, I love that.
And I mean, to that
evil,
point,
invisible
that
glitter.
stuff gets everywhere.
I
have 2 daughters, and I have glitter, and still in places it shows up places like there hasn't been glitter near this for a year at least, and there's still glitter everywhere.
You're gonna find glitter somewhere in Denmark. It followed you there
for sure. And Lightning Rod in the chat room brings a really good point in the YouTube chat room about if you're not trained in how to use PPE like masks and gloves and glasses, then there's a lot of opportunity for you to
do it wrong,
take them off wrong, not sanitize properly before you and after you take them off, all that good stuff that where it kind of it doesn't nullify the effect of wearing the stuff, but it definitely can reduce the effectiveness. So knowing how to do all that properly is important.
It's very important. Yeah. But face shields. something to think about. And we know face shields, if you have a 3D printer, some of those parts can be 3D printed. So it's kind of cool too.
Yeah, I love this story too, because I was not, sorry, last time I'll interject. I was not really a believer in these face shield things. Like, so there's a couple of people on the plane who wore them. And every time I've seen them, like, that's just, it's a barrier, but you're breathing around it. Like, I don't really get it. Like, why are people still doing this? I am now have changed my mind completely about them due to this. If I take the flight back, I think I'll have to pick one up.
I think ultimately it's about compounding risks, right? So like we've talked about droplet this whole time, and now there's this more and more we're talking about aerosol, but ultimately it's both. And so if you can cut off the droplet factor completely, your risk factor just plummets. So there's still risk if it's aerosolized, but it's way less if you're taking the droplets out of the factor, which is what the face shield is essentially doing. If
everybody's wearing pants and holding a shower curtain, the chances of getting clean up.
The analogy grows. A JAMA article compared the 1918 flu pandemic to the current COVID-19 pandemic, looking at excess deaths. And it found that aside from modern medicine and health practices that are probably saving lives today, like we have intubation and respirators and all sorts of stuff that weren't really available, and we have lots of things that were not available sanitation-wise in 1918, the two events are highly comparable. And in fact, the current pandemic might actually, if individuals did not receive modern treatment or sufficient treatment, it could have an even higher mortality rate than the 1918 pandemic. So just looking, and this is just looking at data from New York City, which we know had an extreme outbreak early on. But we don't need to talk very deeply about this right now, because we're going to be talking with one of the study's authors, Dr. Jeremy Faust, next Wednesday.
Nice.
And he's doing a lot of interesting COVID-19 communications, and I'm very excited to talk with him about this, because people have always been like, we don't know, how do we know how bad this pandemic is? And if we look at the 1918 pandemic, it's like, 2 million people died, and how many dead in the United States? 600,000 dead in the United States, like massive numbers. It was huge numbers of deaths. But what is that? How does it really compare to what we're going through right now? And so I think it's going to be, it's very interesting. Final study on convalescent plasma we have talked about previously. There's a new preprint out that is very promising. Some 35,000 people enrolled in this study through the Mayo Clinic. But they didn't have a control group, it was an observational study. So they gave people different amounts of convalescent plasma, so different concentrations, but they didn't actually have a control group. It was not a randomized
Didn't the
study.
FDA just shut down this as a treatment right now?
They didn't shut it down as a treatment. They were looking at giving it emergency use authorization.
Okay.
Which would allow doctors to, it speeds up the ability of doctors to be able to use it as a treatment. But because they didn't have all the data, they have postponed it to actually wait until this study comes out to look at the data from this study and really figure out if they think this study tells them something that they didn't know previously.
Okay.
Yeah, but it's promising. They had significant effects where people who got convalescent plasma, that's plasma from people who have had COVID-19, so it contains antibodies to the SARS-CoV-2 virus, and those antibodies in different concentrations helped people recover more quickly. So people who got higher concentrations of antibodies, or even got antibodies compared to no antibodies, they recovered more quickly. It helped there.
Maybe I'm missing something really obvious here, but wouldn't they be able to compare it as a control group to just the people who didn't get convalescent plasma who have COVID?
Right. Yeah, I guess that's fair.
Yeah, but it wasn't randomized, and there are apparently a lot of confounding factors.
Okay, fair enough.
But yes, you are correct in that. But
I feel like we have a pretty big control group, actually.
Well, so we do, but then
not necessarily,
so,
yeah.
But you could sort of also then at some point say that then you're taking an average of people with and without natural antibodies that they may have been producing.
Sure.
Right? So who might have been surviving it just fine versus people who are having. But then if you just took this, this seems like there's enough data. This has also been the thing, like with the 5 million cases just in the United States, it's like, how can we not have just mined the data on hand yet to find some of these answers? I totally agree, Blair. It feels like it should be a way to suss it.
But that is with the big data mining perspective is, we can mine on all this data, but are we really getting real answers, or are we just finding patterns that look promising but aren't actually real? Especially, we talk about this with respect to genetics, where they take these massive genetic studies and look at all the mutations to see, is there one that is linked to a certain trait? And it's questionable. You have to have incredibly massive data sets, and you have to really figure out what your confounding factors are.
I have to say, at the beginning of the summer, when I thought I had COVID, I didn't. But when I did, when I was lying in bed with 102-degree fever and I was shivering and I couldn't eat food, the first thing I thought was,
kids.
No, at least I'll get to give some convalescent plasma. That was like the first thing I thought. I was like, if I get through this, I'm giving my plasma.
Well, hopefully you won't get COVID anytime soon. But you still might be able to. That's the point.
I'm going to hedge my bets and hope that I won't. But if I do, I'm giving that plasma.
Give it up. If you just tuned in, you are listening to This Week in Science. Hey, I'm wearing a TWIS shirt right now. Do you know how to get this TWIS shirt?
How did you get that shirt?
That's one's from really Patreon, isn't it?
This is a Patreon shirt. Yes, if you become a Patreon supporter, there is one level of support. I believe it's the $25 a month, might be $15 a month. I don't recall, but there's a level of support in there where you can get a t-shirt. I'll send you a t-shirt just like this. It's a nice t-shirt. Head over to twist.org and click that Patreon link if you want a t-shirt. Or if you want us to thank you at the end of the show. I have mystery gas.
Again? Or was that Blair who had it last time? Who had the gas last time?
I think it was Pete.
Again. Oh, this is 2 weeks ago.
I've got so much gas. Oh my gosh. These studies. I do love it. This is out of the Australian National University. Researchers there have been looking at the Milky Way. They've been looking toward the center of the Milky Way. They're trying to...
Sagittarius.
Yes. There's a big giant black hole there, and it's got a lot of it sucking things in. And as it does that, it shoots things out, big giant jets, and those big giant jets, they also emit gas. And there are a couple of different kinds of gas that generally come out of there. The researchers say the wind at the center of the Milky Way, yes, the Milky Way emits a wind with mystery gas. The center of the Milky Way has been the topic of plenty of debate since the discovery a decade ago of the so-called Fermi bubbles, which are two giant gas bubbles, orbs of hot gas and cosmic rays that have formed coming out of the center of the Milky Way. And they observed that there's not only hot gas coming from the center of the galaxy, but also cold, dense gas.
What?
Cold, dense gas. Yeah, so they don't know whether the Milky Way has expelled this cold, dense gas or whether it has come from someplace else. It doesn't move around very well, but it's heavier because it's denser. It's heavier, but it's affecting the kinematics, the movement of the dynamics of the flow of this wind out of the center of the Milky Way. And they're hoping that they can figure out where this gas came from, whether it's really this part of the Milky Way wind or whether it's not, whether it's come from something else. They say it's the first time something like this has been observed in our galaxy. We see these kinds of processes happening in other galaxies, but with external galaxies, you get much more massive black holes. Star formation is higher, and it makes it easier for the galaxy to expel material. And our own galaxy, though, we have to look at it closely to figure out what's going on. What is happening with this mystery gas? You guys don't know what's happening. Nobody knows.
I'm picturing it's like these now like weather map of hot and cold, high, low pressure density zone.
Yeah.
I'm just like maybe that, is it, so there's something that keeps a hurricane together, which is all temperature based on sea level temperatures and air temperatures and wind directions and stuff like that helps them form and then maintain. Whatever, maybe we're just all these galaxies are just big hurricanes of matter.
But it's a vacuum in space.
It's not a real vacuum.
Yeah,
it's close to this. Just because there's close to nothing out there.
There's not a lot.
There's not a lot. Exactly.
But apparently, there's gas.
There is gas. And what they're trying to see here is that this gas is potentially star-forming gas. And because it's being shot out of the Milky Way through these Milky Way winds, it means that the Milky Way could be losing some of its star-forming potential. So what does that mean about the life cycle of our galaxy, the life cycle of the black hole at the center of the galaxy? What is, how does it all work together toward, as far as what we understand for star formation, galaxy formation, and how these things exist over long periods of time?
Just remember, if there's mystery gas, just say, it was the Milky Way.
It's the Milky Way. It was this.
What was that? Yes. Oh, it was the Milky Way.
It wasn't me. It was the Milky Way. Another story of unexplained nature. Researchers were using the Fermi Gamma Ray Space Telescope to look at a number of gamma ray producing objects in our galaxy. They looked at one particular supermassive black hole called SS433, which has high tera electron volt energies of spouting out jets of gamma ray power. Yes. They analyzed more than 10 years of giga electron volt gamma ray data from this space telescope. And they saw that there was a life cycle, or I keep saying life cycle in my stories, but really there was a timing to how the jets moved around this black hole. So black holes, like we talked about earlier, they suck stuff in and then they shoot the jets out. And there's a wobble, a precession of these jets. They're spinning around the spinning black hole at the center. And so they are moving in this wobbly fashion. And they found that there was a timing of that wobbliness of about 163 days. And in the timing, they also just happened to notice another object that was kind of off-center and about 100 light years away from the black hole binary. And they found that it too was producing gamma rays at exactly the same timing as the precession of the black hole jets.
What?
And so what they think is that there's something coming, like hydrogen gas or the nuclei of the hydrogen ions coming from the jets and the gamma rays that are coming out of the black hole that are somehow traveling to this other stellar object to produce gamma rays from that object. But it's the timing of the two objects are the same. So they're going to do more investigations, look at magnetic fields, and really try and see what it is they're looking at there and why there's a relationship.
Are we going to find an entangled black hole?
Right? Is that what it is?
That would be pretty amazing.
Is it a wormhole? Incredible. Somebody didn't want to travel 100 light years?
Yeah, and now it's just spitting out over there too. Wow. Yeah. That's good. That's kind of fun. Could just be a coincidence, but
it could be a coincidence also. I mean, in the whole universe, the fact that things have the same timing, I mean, that could happen. There's probably a high probability of that, but...
And if you're just tuning in to monitor once you found this pattern and you're just sort of tuning in to catch it the next time to see if it's there, kind of thing, maybe you just happen to be picking this. But I do like the other possibilities way more. Yeah, that's really fascinating.
It's fascinating, and it's like these wonderful mysteries. Why is this happening? We don't know.
Or
they're
also
connected.
Kind of like. Yeah, or there's something else that's triggering both. That the black hole isn't triggering this other. There's something else underlying the universe. Some other dimensional brain crashing, crazy string theory-ish type thing that's affecting both at the same time, irregardless of space.
Yeah.
Although interestingly at the same time.
Fascinating questions. We really do not have the answers to at all.
No.
No, we don't. But, more questions equals mo beta for science. That's what science loves.
That'll work.
Yeah, that's the greatest, simultaneous disappointment and, I guess, elation that comes with understanding what science really is it's a lot more asking questions than actually providing answers.
Right. Yeah, a lot of questions and trying to find answers, not always finding them at all.
Not always.
No. Thank you for listening to TWIS. You're the reason that we're able to do what we do every single week, helping us bring sanity and science to people. This world's crazy and full of misinformation these days. Let's use big words and let's talk intelligently. Let's share that. And with your help, we can do that for more and more people. So please head to twis.org and click on the Patreon link and choose your level of support to help bring more TWIS, more sanity, more science to more people. Justin, what you got?
This is researchers at Stanford University School of Medicine. They discovered a way to regenerate cushion cartilage in joints. This is sort of a slippery, shock-absorbing layer of tissue between joint connection points, like in the knee. It is responsible for many cases of joint pain, arthritis. Afflicts apparently 55 million people who have lost or have degenerated cushion cartilage. This is the suffering from arthritis, inflammation, joint pain, that sort of thing.
And that's one of those things they say when you lose it, it's gone.
Yes, because
you have to get surgery to have it returned. And even then, it's not always successful. Sometimes it's very painful afterward.
Anybody who's had an ear pierced knows that those holes don't ever really grow closed again.
Well, they do. They do, though, eventually. So this is Stanford researchers. They figured out a way to regrow what they're calling articular cartilage by first causing slight injury to the joint tissue. Now, that sounds very much like an existing surgery where they will go in and drill little holes and because it's the body's skeletal system that has the stem cells that will go in there and add or remove bone, like when you're getting the rubbing from the lack of this cartilage, but also will do repairs to damage that you do. So they go into a joint and they will drill little holes in the bone and through what material is there. And the skeletal stem cells they've already found will go in there and regrow tissue. Now, what they're regrowing is scar tissue. And that scar tissue is not the same as the cushion cartilage. It has not got the elasticity, the cushioning effects. It helps reduce symptoms, but it doesn't last very long. It wears out quickly and doesn't really have that protection. And this is Assistant Professor of Surgery, Charles K.F. Chan, Quote voice. Cartilage has practically zero regenerative potential in adulthood. So once it's injured or gone, what we can do for patients has been very limited. It's extremely gratifying to find a way to help the body regrow this important tissue. What they found was these stem cells can be given chemical signals to stir them to do the growth of the actual cartilage that's now missing. The work is published August 17th in the journal Nature Medicine. So that old treatment, which was causing the scar tissue, they didn't exactly know how it worked. When they went in at a different lab and figured out, it's actually the stem cells that would be normally responsible for doing a regeneration or building these structures in the first place that are going in there and creating the scar tissue. That's when Chan and his lab started working on, instead of doing what's called the fibrocartilage, which is that scar tissue, a way to get it to do the correct one, or the one that was more desired, or the original. Basically, they figured it out and it worked. They've gotten this to function. So this is like a pretty major development. There've been also materials you're saying like surgery or replacement with artificial cartilages. There've been some massive improvements there in recent years. This is one of those things that, like, when you talk about bodies breaking down as we age and over time, this is kind of a big one. We were talking about the speed at which people move or can walk sometimes determines how long they will live. Part of that is, as you age, it becomes more painful to walk. You want to walk less time because joints now are rubbing up against each other and it's painful. So people get less exercise just out of avoidance of pain, just avoiding hurting themselves while exercising. So being able to restore cartilage to these joints could actually have a very dramatic impact, not just on reducing symptoms from arthritis and inflammation and that sort of thing, but actually allowing people to engage in more strenuous physical activities, exercise as they age, and then prolong, hopefully, human life. Fantastic findings out of Stanford.
It's really exciting. I mean, Blair, you must be thrilled at the prospects.
Hook me up with all that cartilage.
Yeah, I'm looking at the story that you posted, Justin, and the last quote, one idea is to follow a Jiffy Lube model of cartilage replenishment.
Every 3,000 miles.
Every 3,000 miles, you go in for a little oil change.
I mean, I run 3 to 5 days a week, and I have to wear a knee brace now. And it would just be so great to be like, oh, superhero powers activate. I can run like I'm 10 years old.
Yeah, and if that can help to reduce the wear and tear on knees in general, on hips in general, oh my goodness. I mean, how many fewer people might have to go in to get their hip joint replaced? Mm-hmm. That is a major surgery. So
yeah, that's it. That's
and
a huge
the
one.
hip joints
not have to do that.
They don't always last forever. The hip replacements, especially if they're metal, or there can be all sorts of complications after that.
Actually, the modern day ones apparently have progressed.
They're gotten better,
pretty darn far. Like you can get a lifelong one that should outlast.
You can.
The life
Some
of your.
Of them are,
but the first place you're probably going to see this, my guesstimation is going to be sports medicine. You have aging athletes or injured athletes who, instead of retiring earlier, can maintain a level where they can continue.
Keep going. I want to be an athlete that can continue. I mean, not just the super sports stars, the runners like Blair. You know,
but also the educators who work
walkers.
with toddlers, because when you're shuffling around on your knees all day, I think that's actually the reason that I have knee problems, is because you're down on a kid's level holding an animal and you're shuffling around on your knees on a classroom floor.
Oh, absolutely.
It's punishing.
And I don't mean that just in terms of like the benefit of this would be that we could have our favorite sports athlete players last longer in their careers, but there's so much money behind them maintaining a career, and there's so much the sports industry itself has actually, like, we talk about the good that NASA programs have done for technology. For all of the injuries that happen during, major league sports in America, there's a ton of medicine and research and application that takes place that then translates to all physical therapy. We wouldn't have the physical therapy that we have today without our athletes footing huge bills to get those athletes back on there as quickly and healthily as possible. So that's who's going to be able to afford, I think, initially to pay and lend to this research and get that.
Perfect it, get it more widespread.
Yeah.
Yes.
Easier access to the general.
Yes.
Absolutely.
Yes. That's sort of, I always think of sports as really like, for all the things it does, it's really big benefit to society is, medicine, sports medicine, physical therapy, and that sort of, that's the thing it does the best for society. It's like the cheering, the booing, that all happens, but it's really the sports medicine that benefits everyone.
I know I benefit from some of that sports medicine. This is This Week in Science. Do you want to help TWIS grow? Get a friend to subscribe today. Yeah, tell somebody today about TWIS. Share it. Don't keep it to yourself. Share it. Help us out. Blair, is it time for that part of the show where you talk about the animals?
Sure is.
It is. It's time for Blair's Animal Corner.
With Blair.
She loves our creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
I have a story all about bird songs, and I just got back from camping, and one of the lovely things about being out in nature is that you get to hear bird songs. But one of the things that I may never get used to is that some birds start singing very early and very loud. And this study that came out this week from Duke University looks at that. Why do birds sing so loud, so early in the morning? And a new hypothesis is that it actually is a warm-up routine. The morning singing is usually mostly males, and often those songs are meant to impress potential mates and to scare off rivals. And what they found is that the early morning might actually be the best time for them to get the kinks out, to broadcast, to kind of hone their skills before it's showtime. Previous thoughts were that it was actually when the wind was the lowest, so there was less distortion on their sounds, or that the dim light actually makes it impossible to do things like hunt, and so they might as well sing. But this new theory is that it all is about the warm-up. They recorded 11 male swamp sparrows between 2 a.m. and noon for 2 to 3 mornings each. So this is a small sample size. It is one species of bird. So that's kind of my big asterisk here on this story. But what they found was that the song of these swamp sparrows, it's usually a simple trill of up to 5 notes, repeated about 5 to 10 times a second, but that it actually, the trill rate and the vocal range over the course of the morning changed. They started off taking it easy. They sang slower, they had a more limited range, and then they would only start to get that song just right, picking up the tempo, reaching for higher and lower pitch just after dawn, after hundreds of attempts at the song. And the more they warmed up, the better they got. So it might also help get their blood flowing, temperature rising in their throats, all of that kind of stuff helps with the demand of singing as the morning continues. Previous playback by the same research team also showed that a well-sung song compared to a rusty one actually does better with females and is more threatening to eavesdropping males. So a better practiced, a better warmed up song is in fact more effective for these swamp sparrows. So if they have hours to warm up, then their next step now is they want to see what females' responses specifically are to individuals after how long they have been warming up, so that you can see exactly what the advantage is and you know, the percentages and all that kind of stuff. But these very specific trills that they make, where they go high low in rapid fire succession, actually means a precise coordination in the movements of both their beak and their voice box. So it makes sense that a warm up might be effective to them.
I love the idea that it's not just a warm up, but rehearsal, that they are.
Absolutely. Yeah.
That, you know, it's me, la 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 la. Okay, I got this. Okay,
Which might be why that super early morning bird song is just a little bit more annoying if you're trying to sleep in than the rest of the day, is because they're still working the kinks out. Might be a little shrill.
They're waking it up. They're getting the voice box, those vocal cords warmed up and ready to sing at their peak. I love the idea also. I mean, we know from lots of birdsong studies that there is a pathway within the bird's brain where they compare their performance against a model of what the song is supposed to sound like that's in their head. So when they're baby birds, they listen to adults, their tutor, that basically puts an imprint of that song into their heads that they spend the rest of their lives trying to sound like. It's like, I need to sound like this for the rest of my life. And then they go about practicing and crystallizing their song and getting their song as juveniles. And then as an adult, maybe every morning, it's like, okay, I'm going to sound like that song. Today's going to be the day. And then they warm up trying to match what they think they should sound like in their head with what's actually coming out of their throat.
Yeah. Well, most human musicians have an idol or an inspiration or someone that they really admire for their style, and that often can inform their music. So pretty similar.
Birds are very similar in that way. Yeah.
Absolutely. And speaking of growing up and learning bird language, would love to talk about.
I want to do.
I want to talk about baby bats learning bat language.
Oh, yes. Okay. That's different. What?
Yeah. So this is a study from the Smithsonian Tropical Research Institute, or STRI. They wanted to explore how infant-directed communication in bats might be different and how that might result in specific vocalization changes. They were looking at the greater sac-winged bat, Sacoteryx bilineata, and it's found in Central and South America. It has a large vocal repertoire. It has complex songs and vocalizations for territorial defense and courtship. So you know that bats did that? They do. Female choice in mating is very pronounced in this species. So just like the bird songs we were just talking about, which probably led to the complexity of their vocalizations in males in this species. The reason the researchers wanted to look specifically at baby bats and the mothers and their communication is that during their first 3 months of life, these guys start experimenting with what you would consider bat speech. And female and male adult bats respond differently to the babies. They looked at sound recordings of vocal interactions and found that the mother bats interact with pups as they babble, as they're learning the bat language, which could be interpreted as positive feedback to pups during vocal practice.
Yeah. And
then they looked at what they consider the color of voice, which in humans, when we think about baby talk, we think about slow speech, raised pitch, and a change in the color of the voice. It's kind of more sweet or sing-songy. And they found something similar with female bats. Pup-directed vocalizations of adult females presented a different color and pitch than the calls directed towards adults. Male bats also communicated with the pups, but in a way that seemed to transmit it the vocal signature of the social group. So the females had this kind of this baby talk, and the males were kind of providing a template, like Kiki was just talking about, something to emulate in the future. So these results suggest that the adult males serve as guidance for the development of group signatures in calls, but that the females give important social feedback during vocal development. So it's kind of this balancing act between the two of them. The males have this consistent talk. This is how our group sounds. And the females kind of lift them up and help get them there by changing the color, the tone, the cadence of the language as they're learning. So this shows that social feedback is important during vocal development in animals besides humans. And that there's a lot more going on there when you think about people that do baby talk with their toddlers or their infants, that there could be evolutionary reasons for that.
Yes.
So this could be a whole new avenue of research amongst any vocally communicating animal.
Whether or not their babies babble and which individuals respond in which ways and how that training takes place. And especially in social animals.
Mm-hmm. Absolutely.
Yeah. I think that's so cool. I mean, you never really consider, and we have little baby birds that go and they want their food, but they do their little practices and they babble. Little kids babble. Yeah. Who else babbles?
There's also lots of different theories when it comes to raising human babies and whether baby talk is good or bad, or if there's a time at which you need to kind of curb it. But this kind of balances that. You have the baby talk that allows for them to grow and change with what they start with, but you also have the constant of another voice that is giving you the adult language from the start. So having both sides might actually be what's beneficial here. You can do of course, this has not been tested at all, but this is my extrapolation, is that you could potentially, what this could mean is that baby talk is not such a bad thing with human babies for extended periods of time, as long as they're also hearing normal adult speech.
Yes, because that is what will teach them how to speak.
Right.
Yes, but the baby talk is also neurally stimulating. It is going to stimulate the brain, and it's
right. And it gives
I made a noise, and my mommy's making a noise. Yeah,
exactly. Yeah,
and play classical music and bird songs and bat calls to the kids too. And
why
hit
not?
Off. Yeah,
they'll be trilingual before they go to kindergarten. Yeah. I speak human, bat, and bird.
Amazing, absolutely amazing. Do you babble to your babies? Do you babble to your baby bats? This is not really a tongue twister.
Babbling baby bats? That's definitely a tongue twister.
Blair's babbling baby bats.
Yes. All right, everybody. We have come, I believe, to the end of our show. We don't have a question from anyone to answer this week. So if you have questions
We've answered all of the questions?
Science is fixed. We figured it all out. Never mind. Forget about what I said before about questions.
I could have missed an email somewhere. I went searching through my email. It's been very busy recently. I did go searching through there, but didn't see anything that had TWIS in the subject line. So if you have questions for us to answer, send me an email, Kirsten@thisweekinscience.com. Put TWIS in the subject line, TWIS questions, to highlight what exactly you want us to do with that email, and we will try to get to it. You can also ask a question on our Facebook page.
I will say I did get an email correcting my pronunciation when I was talking about tuataras last week. They said the very anglicized Maori when I was talking about native peoples in New Zealand, and it is Maori. Maori is the correct pronunciation. I think I've only ever seen it written. So that was my bad. And I appreciate somebody reaching out and letting me know. Maori.
I think that's important. And to change your pronunciation based on that correction. And I think what's also interesting, there was a study looking at people who have read a lot as kids, that they tend to mispronounce words quite often because they've early on read a lot, but not heard the words spoken before. So there's a large literary knowledge, lexicon, but not actual knowledge of how to pronounce the words correctly. So,
I went to a library once and
that's a thing.
Was trying to get a book written by Nietzsche. I'd been reading Nietzsche for years, but I had never talked to anybody. I hadn't been instructed to read it. I hadn't talked to anybody about it. So I was looking for more books by Nietzsche, who's like my favorite author right now.
There you go.
Yeah, I get how we had the same type of thing happen when discussing Denisovans.
Yeah.
Who turns out to be pronounced Denisovans. But you don't know until you talk to somebody who knows more. Yeah.
Yeah. And if you don't know anybody who is smarter than you need to find some new friends.
Yeah.
Or make your circle bigger.
Or you need to ask your current friends what they're experts on, because somebody's smarter than you at something that you know. Guaranteed.
Although I bet you. So here's the thing, though, is I guarantee that would not have taken place. That going to the library and asking for Nietzsche, where the Nietzsche books are, would not have happened had YouTube existed. Because I could have, watched a lecture by a professor who's talking about Nietzsche, and I've been like, "Oh, Nietzsche. Oh, okay, now I get it." That's how you say that.
Nietzsche.
Yeah, Nietzsche's also not right, but that's okay.
It's not right.
It's close. It's closer than Nietzsche. Nietzsche makes him sound like a Russian author, which I may have thought he was, but he's a German.
Yeah. Keep learning, keep asking questions, and thank you for listening to the show tonight. I really hope that you enjoyed the show. Time for some shout outs. Thank you to Fada for help with social media and the show notes. Gord, thank you for manning that chat room over there. Identity4, thank you for recording the audio for the show. And I would also like to thank our Patreon sponsors and the Burroughs Welcome Fund for their generous support. Thank you to Donathan Stiles, a.k.a. Don Stylo, John Scioli, Eric Holmes, Flying Out, Guillaume, John Lee, Ben Rothig, Ali Coffin, Maddie Perrin, Gaurav Sharma, Josiah Zahner, Mike Shoemaker, Sarah Forfar, Donald Mundis, Rodney Lewis, Stephen Alberon, John Ratnaswamy, Dave Friedel, Dara Myshak, Stu Pollock, Andrew Swanson, Fred S104, Corinne Benton, Sky Luke, Paul Ronovich, Ben Bignell, Kevin Reardon, Noodles, Jack, Sarah Chavis, Paul, Jason Olds, Brian Carrington, Matt Bass, John Fury, Joshua Fury, Shauna Nina Lamb, Sue Doster, John McKee, Greg Riley, Mark Hessenflode, Jean Tellier, Steve Leisman, Ken Hayes, Howard Tan, Christopher Rappin, Richard, Brendan Minish, Melizond, Johnny Gridley, Richard Porter, Christopher Dreyer, Mark Mazzaros, Artyom, Greg Briggs, John Atwood, Robert, Rudy Garcia, Dave Wilkinson, Matt Sutter, Philip Shane, Kurt Larson, Craig Landon, Mountain Sloth, Jim Derpo, Alex Wilson, Dave Neighbor, Costi Ranke, Matthew Litwin, Eric Knapp, E.O., Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul Disney, Patrick Pecoraro, Gary S., Ed Dyer, Tony Steele, Ulysses Adkins, Brian Condren, Jason Roberts. Thank you for your support on Patreon. If you're interested in supporting us, you can find information at patreon.com/thisweekinscience, or just click the Patreon link at our website. On next week's show, we will be speaking with Dr. Jeremy Faust about COVID-19 and his paper comparing the 1918 flu to the current pandemic.
And we will be back at the same time on the same channel.
Yeah, you can watch us from twist.org/live. But if you want to listen to us instead, we do a podcast. This is the podcast. Just search for This Week in Science, wherever podcasts are found. If you enjoyed the show, get your friends to subscribe to my pronunciation. See, it's gone now. I don't speak English anymore. Moving on.
We can correct you on all your pronunciation.
It's found. And if you want information on the stories you heard, show notes and links are available on our website. That's www.twist.org. And you can sign up for our newsletter, too. Hey, Justin, what are our emails and Twitter handles?
We've got twistminion@gmail.com. That's me.
him.
Kirsten at thisweekinscience.com. I don't even know.
.com.
That's Kirsten. And then Blair at
BlairBaz@twist.org is me. And then on Twitter, it's @TwistScience, @Dr. Kiki, @JacksonFly, and @Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a correction of word pronunciation other than the word fount, because I know I did that one wrong.
Fount.
Let us know. And when you do email us, put TWIS, TWIS, in your subject line. Or what happens, Justin?
your email will be spam filtered into oblivion.
That's right. We'll be back here next week, and we hope you'll join us again for more great science news. And
if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. 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 And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 Got a laundry list of items I want to address. From stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought. And I'll try to answer any question you've got. So how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say. And if you've learned anything from the words that we've said, then please just remember it's all in your head. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.